Welcome back to Advent of Code 2018, day 21. 5 days left till Christmas. 2018 Christmas, and then we'll have the actual Christmas. 21. Oh, this looks like another assembly code problem. Yay! Oh dear. The last one was quite tricky. Alright, what have we got? Chronal conversion. You should have been watching where you were going, because as you wander the new North Pole base, you trip and fall into a very deep hole. Just kidding, you're falling through time again. If you keep up your current pace, you should... Okay, let's skip a bit of the flavor. Alright, second, you discover the activation system, your puzzle input. Let's have a look at this. Oh, great, okay. It's using commands that we studied in a previous problem. Alright. Currently it appears to be run forever without halting. If you can cause the activation system to halt at a specific moment, maybe you can make the device send you so far back in time that you cause an integer underflow in time itself and wrap around back to your current time. That? Yeah, sure, that makes sense. That was allowed plain. Device executes the program as specified in manual section 1. Okay, and manual section 2. Wonderful. Fine. Your goal is to figure out how the program works and cause it to halt. You can only control register 0. Every other register begins at 0 as usual. Because time travel is a dangerous activity, the activation system begins with a few instructions which verify the bitwise AND does a numeric operation and not an operation, as if the inputs were interpreted as strings. If the test fails, it enters an infinite loop, rerunning the test instead of allowing the program to execute normally. If the test passes, the program continues and assumes that all other bitwise operations also interpret their inputs as numbers. Okay, I'm getting a bit lost here. What is the lowest non-negative integer value for register 0 that causes the program to halt after executing the fewest instructions? Wait, what does that last... What do those last few words mean? After executing the fewest instructions. Alright. Fine, whatever. This is the program. Oh my. Put that in. It's been a while since I did these commands, so I forget how they work. But we can copy in stuff, I guess. From previous problems. So we want to reuse day 19, I suppose. Okay. This is what we've got for day 19. Put it in. So given an opcode, an A, a B, a C, and a reg, A, B, C being those things, then we assume these are all correct, okay? So do they cover all possible? Well, we'll know. We'll know. IP4. Right. You can only control register 0. Every other register begins at 0, as usual. Wait, what are the... registers here? All the registers are integers. Not letters this time. A, B, C. So the these three here. Oh, so it can go as high as these. I see. Not necessarily. Alright, so regs, I guess, will have to be 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. I assume it goes up to 5. I don't think, like, set I, 7, 2, 4. Set I, yeah. So, alright, we'll stick to using these. Now what? Let's copy in some more scripts then. So 19, we want to do this basically. There's no IP binding. And it takes the IP binding from the input. Alright, when we set, the key thing we can change is this, regs 0 equals, let's say 0. Okay. That's the only thing we're allowed to change. So with, I'll put that down here. Line in f read lines tokens. Okay, so now we've got instructions. And now we run this. So I is the instruction counter. While Wait, what's IP? What's the difference between I and IP? Take that one out for now. Ah, that was just counting how many instructions we do. Take I out altogether, we don't need I. Do we? What was I? IP plus... No, I was literally just okay, take that out. We'll just comment it out. So IP is the instruction pointer, starts at 0. So it will halt when the instruction pointer goes out of the... If the test passes, the program continues and assumes that all other bitwise operations ban are bori and bori also interpret their inputs as numbers. Ban are bori and bor are. Yeah, okay. Just run it then, see what happens. Should be an infinite loop. Okay, stop. Alright, so that's why we had the I thing. We want to see what it looks like. Alright, so now run it. Oh, we want to reduce this. Okay, start again. That's what it looks like now. Problem. Literally solving the unsolvable problem of the halting problem. Alright, stop. So how the heck do we go about this? So I need to AC up. We could detect when we're in a loop. So the moment we hit a state that we've hit before, we're in a loop, right? But that's not the only way of proving we're in a loop, because it could be that we're just increasing a number infinitely. That's also a loop, technically. I don't know. Is that the kind of loop they mean? Yeah, okay, so... So... State. Alright, so... we want to say... Okay. Alright, so states dot add. We want to add the current state, so that's going to be IP plus, or just do it like this, tuple. So it's going to be IP plus regs. That's everything, right? That once you know those two things, that's wait, IP binding. Oh, IP binding as well. I don't remember what IP binding even is. We're gonna have to remind ourselves. Does it ever change? No, IP binding never changes. IP binding is 4. Let's remind ourselves. Let's look at the manual section 2. What the heck is IP binding? Why do we have it? Look at 19. We never change IP binding, so why did we have it again? So IP binding is just 4. I don't know. Zero, 1, 2, 3, 4. Oh, this is the instruction pointer. So every time you try to access whatever IP is bound to, in this case 4, whenever you try to change that, you're actually changing the instruction pointer itself. I get it. But the value of IP binding never changes. So, for some reason they've chosen 4. Alright, fine. 0, 1 to 5. So this one here is the IP binding. Everything else is modifiable. So take out this. Okay, state equals this. If state in states print state break recurring state. So if we see that again, that means we are now in an infinite loop, because it should just go in an infinite loop from that point on. Otherwise, just add it to states. So states is just going to keep growing. IP binding is fine. Okay, now try running it. Will it ever find the loop? Probably not, because I think it can just keep going on forever. You can have infinite loops which don't repeat states. Just counting 1 to infinity, that is such an example. Why is it hanging now? No, it's not. This is hopeless. States just gets bigger and bigger. How are we supposed to interpret these numbers? 21, 23, 24... Would these be like days of December? 17, 20, they're always under 25. Nine one three oh two four. Why is it? I think we're using too much memory. Let's stop the program. So what do we do then? Are we just gonna have to look at this and work out what it's doing manually? This is crazy. So, okay, what's the first instruction? Set I. Reg C equals A, so it's saying... No, don't... Yeah, okay. So it'll be... register 5 equals... Should we just... I see. So the IP binding could be changed in regs. So whenever we see a 4, like here, that means it's kind of here. It's adding 5 to the instruction pointer or something. I don't know. Set I. Wait, set I. Reg C equals A. What's B for? Why set I? So why is there a B? That's A, that's C. Why is there a 6 here? Set I. Let me have a look at the instructions again. Set I. Input B is ignored. Why are they giving us values for input B then? Hello, Amaro. What is this 6? I don't understand. Are they just... Is that there to confuse us? So that number there is never used. That number there is never used. Set I. C equals A. Yeah, there's nothing here which uses it. Okay, fine. They're just trolling us with that number there. Program does what it's supposed to. I just now, how the heck are we going to work out what this program actually does? Am I just going to have to translate this entire program into Python? Because I cannot look at that and see what it's doing. I've got to keep looking up the opcodes. Register C equals A. We got more assembly code programming. This 2018 year had a lot of assembly code programs, and they build on each other, so you have to kind of remember what happened in the previous ones. And they've built up several layers of complexity now, so it's like all these different codes here, which mean different things that have been introduced in previous problems. Basically, we're given this assembly code program here, And the only thing we can change is, so we've got a register with 5 integers, 6 actually. And this code is using that register, so it's changing values, it's copying values, it's multiplying values, whatever. It's modifying the register. But the only thing we're allowed to change at the beginning of the algorithm is the first number here. So it's 0 right now, but we could set it to whatever we want. And we've got to find the smallest number we can set it to such that this program actually holds and doesn't go into an infinite loop. So it seems we have to solve this by inspection. I don't know how I would even program that to detect infinite loops. Because, I mean, technically you can't. This is the theorem of uncomputability. You can't detect infinite loops. It's mathematically impossible. So you have to do it from understanding the code to know if it's going into an infinite loop or not. Because you can't detect infinite loops programmatically. That's the halting problem. I mean, if it's easy enough, if it's something is alternating between 1 and 0, then yeah, you could detect it. But in the generalized way, you can't. You can't, if something's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you don't know if it's going infinitely, or you don't know if it's going to roll back to 1 or stop somewhere, I don't know. So I mean, problem 16 was, no, problem 19 was the last assembly code program. That was a bit of work as well. And then it turned out it was doing something with prime divisors. It was actually summing the divisors of a number. But it took me a while. I just had to keep running it and looking at what's going on and seeing the patterns. Now, we have to do the same basically, but okay, this is what the register looks like every 100,000, 1 million steps. Like, I can't look at that and see any pattern. I see this number here, that's interesting. It always seems to be less than 25. So does that mean something? I don't know. The second number, no, the third number always seems to, usually is 0, but then sometimes it's some big number, so that suggests it's a counter of some sort, like a timer. And when the timer starts, it's counting down, and then it goes back to 0, and then that happens again. So here it's 8 million, and yeah, something like that. Okay. So, okay, the first number always seems to be... Oh no, the first number is what we give, right? So we can control that. Hope 2023 doesn't have something like this. I think the years since he reduced the amount of assembly code problems, but there were assembly code problems, just not as many as this year. But yeah, this one is a real nasty one. I don't think ChatGPT would even be able to solve this, because you have to look at the numbers and see what's going on. You can't just write a code that automatically detects. Like, for 19, I don't think I could write code that automatically works out that this program is finding the sum of the divisors of the input number. I don't think that could even be done. The only thing I can hope to do really is just try and find a pattern here. So the first number we control. Should I try setting it to 1 then or something? I don't know. 1. Let's see now. Okay. No idea what to make of that. Same sort of pattern. This... Let's stop it because it's going to use too much memory. Try setting it to something bigger. 1024. I mean, the most interesting number here is the fourth number here, because this always seems to be under 25. 19, 18, 23, 23. That's the one which seems to have the most regularity, but I'm not sure what it's doing. The other numbers are just kind of huge counters. Oh! Oh no, they did tell us what that one. 0, 1, 2, 3, 4. Yeah, that one is the instruction pointer. I don't know why they decided to put it there, but they did tell us. Yeah, 4. Oh yeah, okay. So that's actually just pointing to an instruction in this list. So that one's 0. So 24 would actually be line 26 here. So we're never going past here. So I'm guessing... if we ever manage to break out of the infinite loop, we'll eventually reach these instructions down here. I don't know. I could try translating this script into Python code. Then I can actually read it. What are these numbers like? Okay, mulI 22562. So that does mulI. Reg C equals reg A times B. So that's saying whatever is in register 2 just multiply it by 256. And put it in the same place. Fine. And you got bitwise ands, you got... Okay, so if register 0 is the only thing we're allowed to change, where does register 0 even get used? I think we just got to translate this into Python code. I can't deal with this. Okay, this one's interesting. 65536. Bori, what does that do? Here. Reg C equals reg A bitwise OR with B. So reg C, so the register 1 is going to be equal to register 5, and then bitwise OR with 65536. But 65536 is it's just going to be 1000 some number of zeros. So all that does is make sure there's a 1 in the 32 to the power 32, isn't it? So it'll be make sure there's a 1 in the 132nd column, if there isn't already one. Fine. Alright, whatever, let's start translating this whole thing into Python then. We have to create a new script here. Oh, we can do side by side here. That would be useful. You know, it would be really nice if I could change these line numbers to start from 0. Can I do that? Line... Is that settings? Let's have a look. Line numbers. Line... Show line numbers. Can you start from 0, please? Because we are programmers. IDE doesn't really have an option for that. Well, these are key maps. We don't care about key maps. I don't know. I'll just have to mentally subtract 1 every time. Okay, let's create another file. Let's call it scrap. So I want this to be side by side. Alright, let's get rid of the IP4. We can do that manually. IP4. Okay. So every time we see a 4, we're actually changing the, we're doing a goto, we're changing the instruction pointer. That's an assembly code thing. In Python, you normally would wrap things around with while loops and for loops, so we have to try and translate it to a for loop or while loop. Okay, let's start with the first instruction then. Set I 12305. So that reg C equals A. Okay, so reg 5 equals 123. Okay, next instruction. Ban I 54565. So that's reg C equals reg A and B. Okay, so reg 5 equals reg A and B. So it'll be reg 5, and so it'll be like this. It'll be and equals 456. So we set it to 123, then we AND it with 456. Fine. equerry 5725. What's equerry? Equerry. So this is 1 if... Oh no, reg C is 1 if reg A equals B, 0 otherwise. Okay, so that's saying reg 5 equals this. So reg A, so that's still 5, equals 72. So it's 1. We change it to 1 if it's 72, 0 otherwise. Fine. All right. Add R 5, 4, 4. Reg C equals reg A plus reg B. So this one says reg 4 equals reg A plus reg B. Reg 5 plus reg 4. In other words, reg 4 plus equal reg 5. Okay, that's the interesting one because that's the instruction pointer. So whatever is here, 0, 1, we're now going to add that to the instruction pointer. So if it's 0, no matter what we do, we always finally add 1 to the instruction pointer. So if it's 0, we just go to the next instruction. If it's 1, we skip the following instruction. This following instruction being that. Ah, okay. I'm sort of seeing where the loop is here, so the next one, set I 004. Reg C equals A. Reg 4 equals 0. In other words, return to the start. Okay. So this chunk here is actually saying we keep going back to the start until this one skips over this instruction. So in other words, until reg 5 becomes 72. Basically is what it's saying, right? While reg 5 is not equal to 72, we do all of this. Is that right? So when it's 72, then this becomes 1. This increases by 1 to skip over this. Okay, yeah, and then we can take these 3 out. So we've translated that lump to that. Okay, that's looking good. We can sort of figure out where the infinite loops are here because we're seeing the while loops. Alright, we're now onto this instruction. So we've got another set I. This number here is meaningless. I don't know why they're setting that to 6. We don't use that. So set I always does reg C equals A. So reg 5 equals 0. So what was the point in this? I have no idea what you're doing. Well, it's... I don't know, have you ever worked with assembly code before? It's horrible. I mean, there's a reason we don't code in assembly anymore. Some people do. I mean, I was taught it when I was in school, because back in those days it was still pretty relevant, but microprocessor programming, but I mean, now we have object-oriented languages so that we don't have to do all this crap, but clearly advent of code want to remind us of the old days. Alright, this is interesting because reg 5 is the only thing that's being changed. So this loop, we now set reg 5 to equals 0, so there was basically no point in this. So... could I just discard these 5 lines? No, because... there might be some instruction later on which throws us into this while loop up here. So the question is, if you've ever found yourself in this while loop, is there any value of reg 5 that could cause you to never leave this while loop? Wait. Hang on. Hang on, I just realized that you're always setting it to 1, 2, 3 here, so it's actually just going back and forth between 1, 2, 3 and... Wait, what is 1, 2, 3 and it with 4, 5, 6? Let me just comment this out. Print 1, 2, 3 and 4, 5, 6. 72. So those first few lines are just pointless, aren't they? Is there any point to them? No, because even if some other line later on jumped us into this while loop here, we would always leave it, because we would always set reg 5 back to 1, 2, 3, and then we would do this, and then you leave it. So it's basically pointless. Okay, fine. We'll leave it alone for now, but that's I think this is the key. We've got to find while loops that can be taken out because they're just redundant. Just thrown in to confuse us. Alright, so here we set reg 5 equals 0. So it's this whole thing was pointless. Let's carry on then. So here we set reg 5 equals 0 and it's like we never did anything before. We're back to the square one. Okay, next. Bori 5655361. So what does this do? Reg C equals reg A or reg B. Okay, so reg 1 equals reg A or B. Okay, so it's going to be reg 5 or 65536. Fine. 65536 is just one with like 31 zeros or something like that. So it just sets. Yeah, okay, fine, whatever. Set I. So this is reg 5 equals that number there. Fine. And I. What's this again? Reg C equals reg A and B. So reg 3, we're introducing 3 now, equals reg A and B. Reg 1 and 255. 255 is 1111 16 times or something. So that discards all the digits before and just takes the last 16 digits. Fine. Add R 535. So add R is reg C equals reg A plus reg B. So reg 5 equals reg A plus reg B. So basically plus equal reg 3. And I. So this is reg C equals reg A and B. Okay. Reg 5 equals reg A and B. Okay, so we do and equal that number. Then we multiply. So I assume that just, yeah, multiply. So we multiply. So reg 5 multiply that number. Then exact same instruction there. All right, next loop. Let's see what this one does. GTIR 25613. GTIR. This one. Reg C. So reg 3 equals that int of reg GTIR reg 3 equals int of 2561. Reg A is greater than B. Oh no, I'm looking at the wrong one. A is greater than reg B. Oh my god, why do they have to have a code for every single combination and permutation? Alright, fine. GTIR, A is greater than reg B. So we want 256 is greater than reg 1. In other words, let's put it this way around. 256. Okay, finally we've got a possible loop here. We've got the 4. Every time we see the 4, we've got a loop. Add R, so it's 3, 4, 4. Reg C equals reg A plus reg B. Reg C equals plus equal reg 3. So whatever's in reg 3, we add it to reg 4. That's the instruction pointer. Alright, so if this is 1, if this is 0, we just do the next instruction, and if it's 1, we skip over the next instruction. Okay. So what does this say? The next instruction is add I reg C equals reg A plus B. Alright, so reg 4 equals plus equal 1. That's a strange instruction. That's meaningless, isn't it? I don't know. Okay, we'll carry on. That's just saying increase... Oh! No, that is saying skip the next instruction, so it's... I see. Oh, fine. Okay. Let I... Okay. Reg 4 equals reg reg C equals A. That's always what it does. Never use B. Okay. Reg 4 equals 27. Okay, I see roughly what's happening now. But I haven't lined them up correctly. No, that's fine. Okay. Reg 4 equals 27. So that's saying skip down to 27. And then the next instruction is I just need to keep writing out codes, because this is sort of doing a not if not true, then go here to 27. Otherwise, carry on with the next instructions. 27's down here, so it's saying this block here is conditional. Otherwise, we just skip here. Fine. Set I reg 3 equals 0. Add I reg 2 equals, it's reg 3 plus 1. I reg 2 equals, so it's going to be times equal 256. I link these together so I always scroll them together. I don't know. All right, 21 GTRR 212. What is this one? GTRR. Okay. Reg C equals that. Reg 2 equals reg 2 is greater than reg 1. Well, we've almost got to the end of the instructions. Then now we can start cutting stuff out soon. All right, add R. Reg C equals reg A plus reg B. So reg 4 equals reg, so it's going to be plus equal reg 2. Would you say this is the worst year? No. Oh, it's hard to remember now what the previous years were like. It's been a while since I did them. I do think the problem with these assembly code problems are that I think people prefer all the problems to be independent. So if you struggle on a problem and can't do it, then you'll still have a chance at all the later problems. But these assembly code problems rely on you having done the previous ones, or having looked at them even. Like, you can't do this problem unless you've actually done the previous problem, and ideally beaten the previous problem. So yeah, that kind of makes them dependent, and I can see why people don't like that, because they like all the days to be a fresh start. So yeah, I think overall it gets weak. The year gets weakened if you have lots of these assembly code problems. So maybe on that merit, yeah, maybe it's the worst year. I reckon the feedback probably kind of reflected that, and Eric used fewer assembly code problems in later years. Because there have been assembly code problems in the previous years, in the recent years, but it's usually only one or two, and they're not as heavily dependent on each other as this year, it seems. I mean, nevertheless, these assembly code problems are very clever problems. But they are very field specific. I think if people haven't had experience with assembly code, they're just going to be completely lost. Okay, now reg 23, add I 414. Reg C equals reg A plus B. All right. Reg 4 plus equal 1. 24, set I reg 4 equals 25. That's straight up skips to 25. That's go to 25, basically. Hang on. Apparently day 23 was the most controversial in 2018. Oh, really? Okay then. Looking forward to it. I've made a mistake up here. Set I sets the instruction pointer to 0, but it doesn't mean... We then have to increase the instruction pointer by 1. So it actually goes to this line here, not this line. So the while loop is actually... like this. Reg 5, it's 1, 2, 3. And now... No, is that what it does? I'm not sure. Let I... Oh yeah, of course, because 0 is actually the... no, it was correct, it was correct. Go back. Zero was actually the IP thing. That just makes things more confusing. Alright, fine. So if we go to 0, if this instruction here says jump to 0, jump to 1, jump to 0, then add 1. But I've cut out an instruction here, which was the hash thing. Maybe I should put that back in. Oh, just... So whenever I see set I, whenever I'm setting 4, what I'm actually doing is going to that plus 1. Yeah. And these line numbers now correspond correctly, because the 0 is actually the IP thing. So when I see set I0, I want to go to 1. Go to whatever this is, plus 1. In other words, that while loop is now correct. It was already correct. Okay, fine. It's a strange loop, but whatever. Okay, so... where are we? Okay, add I 313. Reg C equals reg A plus B. Alright, so add I reg 3 plus equal 1. Okay. 26. Set I 1704. Reg 4 equals 17. Okay. So that actually jumps for this instruction here. Okay, fine. 27. Set R 341. Reg C equals reg A. Why have they thrown a 4 in there? That's just to confuse us. You don't use that number there. It's reg1 equals reg3. That's what set R does. Set I reg C equals A, as always. I've got to keep looking it up because you could easily make a mistake. Set I, so it's reg C equals A. Reg 4 equals 7. That's jumping all the way back here. Interesting, okay. $29. Ecr 503. What's Ecr? Reg C equals that. Reg 3 equals reg 5 equals reg 0. That is the one place where we use whatever integer we put in there. Our special input. Interesting. So basically, if we want to break out of the loop, we want reg 5 to be equal to whatever we set as the input here. That helps a lot. And then finally, the last two instructions are add R 3, 4, 4. Okay, so that's add R. So reg C equals reg A plus reg B. Alright, so reg 4 equals plus equal reg 3. And then the last instruction is set I 514. Reg C equals A. Reg 4 equals just the number 5? Yeah. Alright, that is fully translated into Python. We can throw in some loops now. So this one here basically says go back to line 6 here. And this, okay, we can start putting in some things here. So we've got this whole block here is in one big while loop, while true. Like that. Take that out. While true, just keep doing this. And here, reg 4 is basically breaking, is saying break. So we're saying if reg 3 is 1, then we break out of the loop. So we can actually rewrite this as if reg 5 is reg 0, break. Alright, this is looking better now. Get rid of those crappy instructions. And that's our input there. Okay. What else? Okay, these are the problem lines. These are the go-tos. So we've got go to 7. There has to be a way to do it automatically, otherwise how do they generate the inputs? What do you mean? What inputs? This whole code is the input. Everyone's got different codes. That's what's different. So this is my code. Everyone gets a different puzzle input, yeah. This whole code here is the input. So the creator has a way to generate that, yeah? I guess so, yeah. So reg 4 equals 7. This is basically saying go to line 8. Okay, so we've got another while true loop here. Okay, so all the places where we touch reg 4. Here, 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 here. Alright, so this one is saying go to line 8. Go here. So in other words, we want a while true loop where we do this whole thing. So just take that out. So we want while true with all this. Can't fit. Okay, well we can shorten this. We can say reg 1. Okay. That. Reg 1 equals zero. Hang on. Reg 5 is 0. Reg 1 is reg 5 or... Why would we do that? Reg 5 is 0. We don't have any jump to line 7, so this is kind of redundant. This is just saying 0. 0 or 65536 is just 65536. So unless I'm missing something here... This is kind of redundant. Okay, let's assume it is indeed redundant. See, if I make even a couple of mistakes, if I make even one mistake in this process, I can't exactly backtrack because I'm making permanent alterations to this. So it's all or nothing. Alright, so reg 5. So we're saying reg 1 at this point is just 65536, right? The 0 is redundant. And we might as well put this on this line. And then say while true. And it doesn't matter about the reg 5 being 0 because it's now set to this. So I'm kind of cutting corners here. Alright, there we go. Alright, so far so good. These 3 lines are pointless, basically, so... And no jump ever takes us back into 1, 2, or 3. Because reg 4 is either that. Yeah, so I can just set this to be null. That's just nothing. Okay, fine. Getting somewhere. Alright. We've got to get rid of all these reg 4s, because those are the jumps. Alright, reg 4 equals 17. That's saying jump to line 18. Jump here. Alright. Not just break here. We want, like, the end. That's when we actually finish the algorithm. Okay. But wait. Let me just see what that looked like before. When will we ever get here? When will we ever get to line 29? This one takes us to 28. Something's wrong here. That wouldn't make sense. Why would we go reg 4 equals 27 and then just jump back? We need to get to this line here. 9. Oh. This seems like a solid infinite loop to me. I don't understand how can we ever reach this line here. This line is always taking us back. This line is taking us back. This line is taking us here, which is taking us back. Yeah, it's modifying reg in place. Maybe there was a mistake in day 19? Well, they would... I mean, if there was, I guess it would say by now, wouldn't it? I don't think so. Normally there aren't any mistakes. I mean, they would have updated the website if there was. But... No, I mean, lots of people will end up having the same input because it's not a unique input for everyone. So there's gonna have been lots of people who had my input, probably. Mistake in your code from day 19. Oh, it could be. I don't know. I'll have to go through these manuals and see that it's doing what all these things are saying. Ugh. There's just too many of them. Yeah, I'll have to check each of these one by one. It's easy to get one wrong and still get the problem right, because I don't think it was even using all of them. Yeah, alright, next time. I can't do any more of this today. Alright, yeah, next time I'll just kind of not rely on my code from 19 and just kind of check it all from scratch. Welcome back to Advent of Code 2018, day 21. Day 21 remains unfinished because I failed to finish it last time. And I've actually had to think about it, usually when I'm trying to sleep. And I realized I made one critical error, which could be all I need to properly solve this problem, but it might not be the only issue. But anyway, so quick reminder. Basically we've got this assembly code program, and this is the program. All right, the mistake I made was, okay, so that top line is not line 0. That is line 0. No, if you think of it as a text file, okay, that is line 0 or line 1. Or, what I mean is that is instruction where program counter is set to 0. So that was my mistake. In fact, that when I first coded it, I actually did that correctly. Then I changed it because I don't know. I thought I was wrong. Okay, so if I adjust for that, that might be what I need to make progress here. So let's try and fix that. So that is, we can actually just take that out. Well, no, we'll just leave the input as is. Leave the input to be exactly what comes from the website. I think that's a good practice to follow. Just remember that this is instruction 0. Line 2 in the IDE, but it's instruction 0. So let's adjust for this. So go back to this. So if bindings, this is the key here. That is wrong. Don't put a none in there. Why did I put that? Because that wasn't in problem 19. So if it wasn't in problem 19, then, and I don't know. Hello, Zen. Banana. Oh, wow, yeah. I still have that banana in there. We don't need banana anymore. It served a purpose. The purpose was we wanted to make the program crash if it ever tried to interpret banana as an integer. But, alright, so... let's fix all this. So the first... So we start with 0. IP binding is none. Set it to 4. And then that's fine. Okay, instruction pointer should be 0. While IP is greater or equal to 0 and less than length of ints. Okay. Now, the other thing is, so line 30 is the one where we want to check against reg 0. So if so line 30 is actually instruction number 28. So if we ever get to instruction 28, print print reg 5. Okay. Otherwise, we just do everything as normal. State, we don't need that. Yeah, keep that, keep that, keep that, keep that, keep that. Alright, let's run it now. Alright. What's going on here? That doesn't look right. Built a game with Python? Not quite. I'm building a program. How to describe it? I'm given a program in assembly code, and I'm trying to run it in Python and figure out what the program does, basically. It's just a really annoying puzzle. Assembly code is such a horrible language to work with. I mean, when I was in school, we were taught assembly code, and I thought that was all programming. And so I was like, I don't want to be a programmer if this is what I have to do. But then later in life, I realized that now we have nice languages like Python. So if they had, not taught me assembly code in school, then maybe I would have been a programmer at an earlier age, but whatever. Yeah, it's close to what the machine is doing. It's directly going to different memory locations, putting stuff here, copying stuff here, yeah. Right, so now what's going on? Like, I was about to having conversation with my vacuum cleaner. Yeah, that's basically what assembly code is, maybe? I don't know. I mean, are vacuum cleaners really smart these days? I don't know. I only have experience with the ones where you literally just press on and off. Oh, I guess there's like the Roomba, the one that is programmable. Yeah, I suppose. So now... So if I set... No, we never hit this line. Why does the program terminate? Ah. Oh. Take that out. Again. Okay, stop. Interesting. So... if I set reg 0 to that, what happens? Now take out the break. It actually, the program actually halts? Is that the answer then? Somehow I don't feel like it would be that simple, would it? Oh! Fuck. So actually that problem's extremely easy. You just run it once, check what it's comparing regs 5 with, and set reg 0 to be the same as regs 5, because that will cause the program to halt. All this other crap in there is just there to confuse you. I spent, what, like 2 hours last stream trying to convert all this assembly code to Python just so that I could actually read and understand it. Look, I've got all this here. But the key really was just that line right there. That is the line which stops it being an infinite loop. And if you want to stop it being an infinite loop, you need reg 5 to be equal to reg 0. So you just change reg 0 to be whatever is reg 5 at that time. But to be fair, you kind of needed to translate it before you realize, unless you're good at reading assembly code, because I couldn't immediately see that that was the key line. But then again, it's the only line which is using ecro, and ecro is the branch condition. I used to have this coding class, but dropped it soon later since it involved too many math. Well, yeah, coding is very maths heavy, and I would argue that the best coders are the ones that, well, are the best at maths. But I mean, there are some branches of coding which are like front end or web design or web dev, which are not so maths heavy. It's getting easier now because there are more libraries out there which you can use, which obscure away a lot of the heavy maths, and of course there's AI as well, which is kind of helping people code. I think mostly it's a good thing. I know for this competition they banned AI because it spoils the competition, which is a decision I agree with. And I know it's becoming a problem in universities, but hey, when I was in university, we had to write our exams. You know, we had to do our exams right there in the room with the teacher in front of us. So, you know, just go back to doing that, and then AI won't help students cheat because they have to you know, write it there and then. Alright, well, we have to solve part 2. In order to determine the timing window for your underflow exploit, you also need an upper bound. What is the lowest non-negative integer value for register 0 that causes the program to halt after executing the most instructions? Huh? Ah, I see. I see. Okay, so this... The first time... So we were only printing the first time that line is executed. And at that time, reg 5 was this. So we set reg 0 to be that, and then it terminates. But that's only the first time. The second time it hits that line, reg 5 might be something different. So if we wanted it to halt on the second time and not the first time, make sure you have coffee. Oh, bollocks. I have coffee, but I'm out of water. Oh, fuck. So, I can't make coffee right now unless I were to run to the supermarket and leave the stream running. Oh, have I got some water lying around somewhere? I might. Oh. I kept this from the last airplane. Free water from the airplane. That's not enough for a coffee, is it? Maybe for an espresso. There's still a bit of water in there. Alright, it's espresso then. Water more important. Yeah. It's true, I don't drink enough water. I normally just drink coffee and beer. Alright. That is like 250 milliliters. I think that's fine. Alright, so what we want... Being in front of monitor, we more likely need coffee. Yeah, that's probably true. I only started drinking coffee ever since I became a programmer. Before that, I didn't drink coffee or tea, really. Maybe tea sometimes. I normally just didn't drink anything. It wasn't very good. It's better that I drink coffee than nothing. But, I think what we want to do here is print reg 5 every time it comes up. And see what all the possible reg 5s are, because we want the last reg 5. He is fine, yeah. I really like it to be strong, though. Like, I don't know, I just always have a desire for something to be as strong as possible. And I like the tea to be, like, have lots of, like, I don't know, cinnamon or herbs and stuff. Like the Indian spice teas, I much prefer. I don't like the English teas. I like my tea to just have lots of spice in. Alright. So I think we should just... The sooner I complete this problem, the sooner I can switch to a video game and actually relieve my mind. Not have to think. Oh, the thing is, the games I'm playing at the moment are really thinky games. Thinky games. I just need something mindless like Halo or something. Chai Wala tea, yeah, that's good. But here in Thailand, the Thai tea is just full of sugar. Thai people just love sugar and everything. They put sugar in their fried pork. Like literally, if you go to a Thai restaurant and you order grilled chicken or grilled pork or something, or rice and stuff, they'll put sugar, you know, a sugar bowl next to your plate so you can put sugar on it. It's like, what? Why? I love sweet, yeah. Alright, let's try and print regs 5 every time. Every time we see it. Let's see what happens. So, set that to 0. Now let's go. Huh. So it just keeps changing. So how do we... I think we gotta detect the loop. Tastes like pineapple. What are you referring to? The chaiwala tea? Or the Thai tea? Thai food. Oh yeah. Well, they... Pineapple, I guess. Well, I mean, unless you have pineapple in it, yeah, you're right. There is a... They do like to have every sense, tickle every sense on the tongue. So that's sour, sweet, salty, umami, everything. Yeah, you do get the pineapple dish, which is literally served where you have rice and chicken inside and a hollowed out pineapple. I avoid pineapple though, because it makes my gums all... gives me sores on my gums. I guess we want to detect the loop, so we want to know when it's got stuck in a loop. Alright, see if we can detect the loop. It's stopped. Why is it stopped? Is my computer running out of memory? Is my stream going to crash soon? That has happened once while I was doing one of these. I'm still good. It's still running, so why... Oh, still going. Damn, how are we gonna... Hello, Amaro. Happy affiliate anniversary. What? What's that? Did my stream say that? Okay. How do I turn that stupid thing off? I don't wanna have an affiliate anniversary. To me, it's just an arbitrary day of the year, isn't it? I don't know. It seems like it's just a Twitch thing I can't turn up. Alright, well, thank you for the well wishes anyway. Progress, yes. I solved part 1. So actually it turned out to be far, far simpler. Let me stop this program because it's going nowhere. So, the mistake I made, and it was a pretty stupid mistake because originally I did it correctly. That is not counted as an instruction. That is the first instruction. Okay, so that's what it's supposed to be. And I coded it like that originally. Then at some point I decided to change it, which meant altering the code from day 19. But I shouldn't have altered the day 19 code, because the day 19 code was correct, so I was just being really stupid. So yeah, I counted that as the first instruction, but no, that's to be ignored. That is the first instruction. So it was one off. So yeah. And I didn't even need to translate anything. Basically, I needed to run the program until it compares reg5 with reg0, and just set reg0 to be whatever reg5 is. Yeah. Which, I mean, I realized that last stream, but I was just thrown off. I was completely confused because I didn't see how you could ever get to that line because I was 1 off on the index. So yeah, okay, so we're getting somewhere. So that's solved as part 1. Now, part 2 is harder because... So part 1 was we want to find the value of reg0, which causes it to terminate as early as possible. Now, we want the value of reg0, which causes it to terminate as late as possible. So we're allowing it to do this line multiple times with different values of reg5. We want the last possible value of the value of reg0, which makes it the last possible. So that's really weird. I think so. I'm now printing reg5 every time that line gets looked at. This must be a loop. It must be looping around these numbers. So we just got to figure out what the loop is and just take the last one, right? So if I just print them but don't print duplicates. Part 2 is just getting the last unique number before they start. Oh, have you seen this before? Have you already had a look at the part 2? Yeah, so unique number. So basically put them in a set. Let's try and do that. So if I finish this early, then I could actually maybe play a video game for a change. And it won't be Sonic this time, thank God. But Pepsi Man is coming up this week. Oh man. Pepsi Man isn't any better. Well, I've got a whole week before I have to do Pepsi Man, so I've got time. Or Quantum P1. So the next game has been announced, and that is Super Mario Kart. This was Quantum's proposal, but Quantum, I think, wanted to kind of skip next week because he's literally getting married next week. But it's his proposal, so he has to play it because he has to win and beat everyone and get all those points. So he's gonna be like at the wedding, at the aisle, and like they're gonna be asking him to come up. And he's like, "Sorry, I'll be with you in a minute." He'll be trying to play Super Mario Kart and beat it. All right. By the way, this is Super Mario Kart for the SNES. The original. It looks good. I think I'll enjoy it. I don't think I'll be any good at it, but at least I'll enjoy it. Super Mario Kart looks fun. I was never into Super Mario Kart. I was more into Crash Team Racing, to be honest, even though it's a rip-off of Super Mario Kart. I thought Crash Team Racing was actually the better version. Personally, I know that a lot of people... that might make a lot of people angry, actually, but... What am I doing here? Okay, we just want to... regs 5 set equals empty set. If regs 5 not in regs 5 set. I only work 6 days in December, so I should be able to do AOC 5 days before 25th. Yeah. The first couple of weeks, or the first week or so, well, some problems you'll be able to get like 2 or 3 done in a day, maybe, if you're willing to put like 4 or 5 hours into it. And then the later problems do take up a bit of time, but... What language are you planning to use, by the way? Putting a number in a variable name, that's... I don't often do that. GML. Have you tried solving any past problems using GML just to get a sense for what it would be like, whether it's good? Alright, let's try running this then. So we're trying to find the last... There's still a lot of them. I think we still have... I think this might not be... I think we might not be able to run this programmatically. We might actually have to semantically figure out when it starts repeating. Which would mean we have to translate it and understand the code. I can leave that running for now because it's not using too much memory. It's not storing the states. Alright. So that means... Also, we have to fix these while loops as well. Just compare them against each other until one repeats. Yeah, but it could be... It could take too long until there's a... No, if one repeats, that doesn't mean anything. Because... the next one might not repeat. This is just the value of regs 5. Regs 5 might revisit old repeat values at times, but it doesn't mean it's following a sequence. You only get a regular sequence if all the regs, all of the regs and the whole reg set is something that it was before, because that's what decides what will come next. So, I mean, we could be here forever. It looks like we're in the tens of millions, but it's asking for the last value before it loops. Yeah. Before the program loops. But the program hasn't looped yet. Otherwise, we wouldn't be seeing these numbers printed here, because these are new, unique numbers. So if one number repeats the previous one, but the program isn't looping yet. I don't understand what you mean. I mean, we need the program to hold. We need the program to actually hold, not loop. I mean, regardless of whether it holds or loops. Oh, sorry, yeah, we don't. We need the. Yeah, if you see one number repeat, that doesn't mean anything. I don't know what you mean, because that doesn't mean the next number that comes up might not be a repeat of a last number, in which case that next number is a new unique number. So just because one number repeats doesn't mean that's the last unique number, does it? Probably is. But if that were true, then we wouldn't be seeing these numbers on all these new numbers. Well, I've just proven, basically, it's not true, haven't I? Because if I had taken one of the repeats from before, I could have done it better by taking one of these newly appearing ones. Are they new? They have to be. Well, if I've coded this correctly, they're new, yeah. If regs 5 not in regs 5 set, print it only if we haven't seen it before. And add it to the set. So if it is in the reg set, we skip it, we don't print it. So these are all new, that never been seen before. Yeah, just wait until it's done. I don't think it's gonna be done in the next 1,000 years. I think there's a lot of numbers. Well, not in 1,000 years, but I mean, we're in the hundreds of millions, and it's, I don't know how much time is, how many milliseconds it is between each one of these, but I don't think it's going to get done anytime soon. I think that's the point of this problem. We have to... The printing is what's slowing it down. Just print the last unique one. You can't. How do you know which one's the last one? The program... No, that's why I have to print each one, because the program just runs forever, doesn't it? So you don't know which one's the last one. You don't know, because the program doesn't hold, so you don't know. There's no way you could know when the last one will be. So I think what we need to do is we need to figure out what's actually happening to regs 5 and work out what loop it follows mathematically, I guess. I think it takes about 8 minutes with this solution. Based on what? I mean, you could be right. It could be a matter of minutes. If I had taken some measurements and counted how many we get each second, then all the numbers are like less than 20 million or so. So maybe. I don't have any growing stacks or data structures here, so it's not going to run out of RAM, I think. So I can just keep the program running. And it's not going to crash my stream, hopefully, like last time. But that was because I went over the system recursion limit. Yeah, maybe. I mean, I'll leave it running while I continue thinking, but I think we have to get rid of the loops which are not contributing to anything. So, because they're just delaying it, aren't they? So reg 5 is affected by So what do we do with reg 5? We set it to be 0, and then we set it to be this number. Okay. And then we add reg 3 to it. Then we perform this operation. Then we multiply by this. Then we perform this operation again. That's it. That's all we ever do to it. So the only thing it's ever affected by is reg 3. Okay. Alright, so let's have a look at reg 3 as well. Reg 3 is affected by reg 1. And then it's set to 0 here. You add 1 here. That's it. So reg 3 is only dependent on reg 1. Reg 1 is dependent on reg 5. Well, that makes it circular, doesn't it? And reg 3. Okay, so reg 1, reg 3, and reg 5 are kind of mutually dependent. They all depend on each other. But nobody ever looks at reg 4. Oh no, that's the instruction count. Damn it. No, okay, reg 2. Reg 2. Nobody looks at reg 2. So what's the point of reg 2? It's just time wasting. Let's have a look at reg 2. Reg 2. When's the first time we touch reg 2? Here, reg 2 is reg 3 plus 1. Then you multiply it by 256. And then you see if you're bigger than reg 1. And then you add reg 2 to reg 4. Oh, but that changes the... So reg 2 is either 0 or 1. So either... If it's 0, then we skip over this bit here. So we don't go to the end. If it's 1... Okay, reg 2 is not, I don't know, it's not really wasting time because it's not a big loop or anything. It's not doing any major calculations. I was hoping I could just get rid of one of the regs altogether, but I don't think so. I think we need to translate this properly. Right, well, I'll leave the thing running. It's still running. Let's go back to these loops. So we've got the first while was because we had so add R. What did add R do again? Reg C equals reg A plus reg B. So instruction pointer equals reg 5. We add the instruction pointer. Okay. And this one sends us back to the start, i.e. here. Okay, so that loop is correct, right? I mean, and it's not important. We can actually just cut it out because it doesn't really matter. But anyway, All right, next. So we looked at this one here. Set I. To print less stuff, you could reverse the condition. What do you mean? Just print once if it is in the set, then check the previous one. What? I don't understand. I mean, that could be more, because if there are more in the set than there are, instead of printing what isn't in the set, stop when one is in the set and print the last number in the set. What do you mean the last number in the set? The last number that was put into the set? But every time we see one of these, it's a new unique number. So if you stop early, you're missing all these later ones, which are actually better. So it's not the answer, is it? Every time every time I stop early, all these new ones which are getting printed are better candidates because they all are later unique numbers. So I don't see how you can ever stop early. You have to be printing all of these. Doesn't seem to be slowing down either, so... I think it doesn't repeat a number at all until the solution has appeared. That would be a massive assumption, but if it's a linear... If we think reg 5 is a, what's it called? I mean, you might be right. A linear sequence, then yeah, it would be in a loop. There's no reason why it would be, though. It could not be in a loop. But should we try that then? I mean, that might work. Oh! It's not printing anything new, but I think the program might have just hiccuped. Copy that number just in case. Well, the program hasn't stopped, so we might see some new ones. Let's just wait and see. Okay, so if you're saying that you're assuming that reg 5 is going in a cycle, and that might be correct. There's no reason, we don't know that to be true, but I mean, it could just be that they made it nice and reg 5 goes in a sequence, a circular sequence. Looking at these numbers, it might be true. So yeah, that you could do that. Alright, it does seem to have stopped, in which case you might be right. It may happen to be in a circular sequence. Now, if what you say is true, now every single one has been seen before. Should we just try running? Let's try that answer then. I haven't proved the assumption, but whatever. Yeah, it is. Okay. So I think either you can take that guess, or you can look at the program and probably kind of work it out mathematically. I mean, it does look like a linear sequence. You're adding reg 3, then you're performing an and then you're multiplying, then you're performing an and. So, yeah. It's been a while since I studied number theory, but I think you could mathematically argue that it is actually a linear sequence which is following a... I mean, well, these numbers are not prime. Or 65899, is that prime? Interesting. 65899 is prime, so that suggests it may be a... It may actually be a circular sequence then. Okay, fine. I'm not going to investigate any further. We got the answer. I mean, technically the program didn't halt, it just kept going, so there could have been new numbers appearing afterwards, but... Right. So... That's 21. Let's have a look at the... People solved it pretty quickly, but I guess it can be solved pretty quickly if you just... Okay, part 1 can definitely be solved pretty quickly. Part 2, I think probably some people just looked at the assembly and realized what the sequence is going to be, and then they worked out mathematically what the final number would be. It's probably not too hard to do that. Maybe using, I don't know, like the Chinese remainder theorem or something. There's theorems which are equipped to deal with this. Okay. So, do I want to carry on today? I'm not sure. But is 22 going to take a while as well? Let's have a sneak peek at 22. Square regions, coordinates, erosion, geologic modulo, rocky, wet, narrow. What is all this? Good sort of map. How fast did people do it? Bit longer, but not that much. 21, 22. More people got stuck on part 2 than this one. But difficulty-wise, it seems easier than this one. Well, I think I'll tackle it tomorrow with a fresh mindset. So I have time now to actually play a game which I haven't been able to do in a long time, which isn't Sonic or something trash. Sorry, Sonic lovers. What have I not played in a while? Fire Emblem. I've been leaving that for a long time. Maybe I'll switch to that. Alright, if I'm doing that though, I need to close the stream for a while because I need to change a lot of things. Okay, well I'm glad I managed to fix that program because that was bugging me. I realized, like in the middle of the night, I realized that was probably... That IP4 was probably not counted as an instruction. And that was probably my issue. Yeah, okay. Alright. So we got 1, 2, 3, 4 days left. I'll probably have time tomorrow to tackle 22 then. Alright, nice short stream. Well, it still took almost an hour though. I guess I had to run that program for a while. Alright, thanks for stopping by, Omaro. And I'll try and set up for Fire Emblem now. Alright, see you next time.